Hello everybody, this is a follow-up video to my recent posts around using Cisco modeling labs to create some little scenarios and environments to help with, well, any certification study, but really I'm focused on the CCDE, so some of these labs will be a little bit more complicated than some people might be doing themselves, but yeah, the purpose of this is really to just make sure that how I believe a protocol actually operates that way. And the reason for this is there have actually been times in the past where I've read something, had an understanding of how something works, and it's not really until like I've labbed something up with 5 or 6 devices that it's become apparent that it might operate slightly differently or there may be quirks. So here's an example of the type of topology that I would put together for CCDE practice. And let me just explain, but before I go into explaining what I do is, it's pretty cool that we can now lab up, and probably for some time, being able to lab up like different types of devices, and in particular higher end devices like the NXOS switches. So here we've got some NXOS 9000 series switches. I've only got a couple of these switches enabled at the moment because I'm still working out how many I can run on my laptop. It's quite a beefy laptop, but I just got a couple of nodes running there, so you can see NXOS 9001 and 9000-6, but I've created like a spine and leaf topology, and the idea is that these devices 2, 3, 4, 5 will be the VTEPs, so the leaf nodes. This will be the leaf layer 3 out connection to an IOL or an iOS on Linux connector, and then that connects to my PC wireless card, which bridges a connection out. So in theory, we should be able to, for example, connect a Linux host here. There will be an underlay network, which I'm planning, I'll explain a little bit what I'm planning to do about that in a second, and then a VXLAN overlay where I can effectively connect to the internet if I have the internet up here and say Google DNS servers 8.8.8.8, that I can connect over the VXLAN overlay and then out through the bridge NIC and out my home internet connection in order to provide connectivity from this CML lab. Now, the system requirements for the NXOS 9000 virtual switch are below. So if I was to set one of these up, you can see here that there's 8 gig of RAM and then 2 CPUs. What I would say is that it does take quite a while for these things to boot up. I'm talking like 15 to 20 minutes. You can see that I've got 2 of them running at the moment just with the standard settings that come on CML, and yeah, it took about 15-20 minutes. I tried to make this one have higher spec, but it didn't actually seem to boot up that much quicker. So I just decided to keep them with the defaults and see what it is. But yeah, fully fledged. So let me just show you here. If I look at this spine switch and I want a console to it, anyone who's familiar with CML will already know how to do this. But you can see here that I've got a fully blown NXOS 9000B. If I just make that fit to the screen. This is the terminal window that comes with CML, but what I prefer to do is actually connect via my own preferred terminal program. I typically use Secure CRT, so the way that we're going to do this is that I've installed an additional program called the CML Breakout tool, or the Breakout user interface, and there's other instruction guides online that tell you how to use this, but in summary you can see that I'm running a lab here, so the NXOS VXLAN lab, and when I go into that lab I've got a couple of different nodes, which is just the actual node label or the host name, NXOS 9000-1 and -6. So if you go back to my topology and zoom in a little bit, you see that O1, which is connected within the spine leaf topology, and then NXOS 9006 is connected. It's not actually connected to anything. However, if you come to this breakout tool, you can see that I will be able to access these by connecting via telnet to the local host and then port 9000 for the NXOS 01. So this spine switch is port 9000. So just like a console server, and then the NXOS-6 would connect via port 9001. So if I just show you that in action, if I go to secure CRT, if I just show you the properties of this one, because if we go to the telnet session, you can see I'm telnet into the localhost 9000 is the port, and I just want to connect to this. If I just double click it, should work. You can see that there's no login or anything like that, but what I type here also appears there. If I do a show version, you can see that it's a NXOS switch, an NXOS switch. You can see from the show version, and then you can do things like check the features that are enabled, and you can see that it's got all the features here. Scroll down here, you've got layer 2 VPN, layer 3 VPN, and NVE and VNI somewhere down here, VNI. So these are all like the VXLAN things that I'm going to use. And then if I wanted to connect to the other device, which is NXOS 9000-6, then I need to use port 9001. So if I click here, and let's just change this. I do have a 9001 somewhere else, but I'll just reconfigure this one. Start up a new session. Okay. And you see here, insert hostname here. So it's because I've not done anything with this device yet. Insert hostname here. So if I do conft hostname NXOS OS-02, well, I'll call it 06 because it's keep the name and terminology the same, NSOX 6, and then I go back to secure CRT. You can see here, similar kind of thing. Show version, we've got an NXOS. So I know this is like pretty basic stuff that I'm showing you here, but I think it's awesome that we're able to do stuff like VXLAN on Nexus, when, you know, earlier in my career the only Nexus that we were able to access were things like the Nexus 7000, so you just had to hope for a project in order to get exposure to those types of things. Anyway, that's it for today. I'll be working on these labs, and well, I've not got that much time to tell you in this video, but I'm looking at working through some of this stuff, configuring the underlay with different IGPs, so we can configure an OSPF underlay or an IS to IS underlay, and there's even an eBGP underlay section before we start getting into configuring VXLAN between the different VTEPs, which are the leaf nodes in the infrastructure. So yeah, that's Cisco CML. Key point here is that these NXOS 9000s took my machine probably 15 to 20 minutes to load. If you've got CML, wish you good luck with it and hope you have fun. Cheers.